IBESS, Biodiversity Conservation Part 4, is the first of two movies on the impact of people on the Earth's biodiversity. The essential idea is, while global diversity is difficult to quantify, it is decreasing rapidly due to human activity. Here's the outline for the diversity conservation movies. Use this slide to find the movie you need for review purposes. This movie is focused right here. Here are the first two IB syllabus statements that kick off this movie. Describe the human activities that cause species extinctions. Describe the human activities that lead to a loss of biodiversity. The acronym used to help remember the 5 impacts of humans on the world's biodiversity is HIPPO: habitat destruction, invasive species, human population growth, pollution, and the overharvesting and hunting of species. This movie will look at habitat destruction and the introduction of invasive species as the activities that reduce Earth's biodiversity. Let's start with habitat destruction. Humans reduce habitat through the cutting of forests. Deforestation also results in the fragmentation of natural habitat. Small fragments do not support as much diversity as large fragments. The relationship between area and diversity was covered in Part 1. Keep that relationship in mind. Forest cover has been reduced 20% in the last 100 years. 50% of harvested wood is used for fuel. 2 billion people depend on wood for fuel. 63% of the world's forests are secondary growth forests. In other words, the forest has already been cut and is now growing again for the second time. 22% of the world's forest is old growth, never having been cut. 5% is plantation. 25% of commercial wood comes from plantations of trees. This photo from Malaysia shows a tea plantation on the left and original forest on the right. You can imagine the impact on local diversity when forest is replaced with a plantation of small bushes. Deforestation reduces the world's forests by 50,000 to 170,000 square kilometers per year. Half of the world's remaining tropical forests will be gone in less than 100 years. This diagram displays the deforestation of Borneo from 1950 and projected out to 2020. As tropical rainforest habitat, the deforestation of Borneo has had dramatic consequences for endemic species. Consider the orangutan. Tropical forests throughout Malaysia and Indonesia are being replaced by palm oil plantations. In this photo, you can see a monoculture of palm oil. This is not a diverse ecosystem, and you need to think carefully as you compare it to the ecosystem that it replaced. Vast regions of tropical Malaysian forest have been replaced by palm oil plantations. Here is a photographic comparison of Rhondonia, Brazil in 1975 on the left, when just over 1% of the land had been cut, and in 2001, when nearly 16% had been deforested and replaced by savanna. The grasslands allowed the grazing of cattle and the raising of sugarcane. The sugarcane can be fermented to make alcohol to be used in automobile engines. Once a road is constructed into the forest, it brings miners, farmers, hunters, and loggers. Tropical farmers typically burn a forest to clear the way for grasses. This is known as slash and burn agriculture. This is a satellite image of the political boundary between Haiti on the left and Dominican Republic on the right. Haiti has been severely deforested while reasonable environmental policies in Dominican Republic have maintained the forests. The UN Food and Agriculture Organization monitored forests from 2000 to 2010 and found losses across many continents. Worldwide forest cover declined 1.3% in 10 years. This graph shows the annual change in forest area in different biomes from 1990 to 2000 and from 2000 to 2005. The net change is given in blue. You can see a slight net gain in forests in boreal, temperate, and subtropical regions in both time periods. But there were large net losses in the tropics and the world generally. The loss was greater in the 5-year period 2000 to 2005 than it had been in the 10-year period just prior. This suggests that deforestation is accelerating. WWF, an NGO, works to raise awareness of tropical deforestation. In this image, the forests are being equated to the lungs of the world. As a product of deforestation, small patches of original habitat are left standing. This is called fragmentation or islandization. In this photo that I took in New Zealand, you can see islands of forests. Habitat fragmentation is defined as a change in habitat configuration. What you have is remaining patches being smaller and more isolated than in the original configuration. In this diagram, you can see the fragmentation of Greene County, Wisconsin from 1831 to 1950. The fragments are far less diverse than the original forest. As you will soon learn, the perimeter to area ratio increases when fragments get smaller. The perimeter is the source of disturbance and invasive species. If the perimeter to area ratio is larger, species diversity is lower. And so it is with small fragments. Here are the old growth forests in the U.S. in 1620. Pay attention, I'm about to show you 1990. And here are the old growth forests in the U.S. in 1990. And most of these forests are within the national park system. Protected? Sort of. Smoky Mountain National Park here gets 9 million visitors per year. Here is a quote from David Quammen, a well-known writer of science, about fragmentation. Let's start by imagining a fine Persian carpet and a hunting knife. The carpet is 12 feet by 18, say. That gives us 216 square feet of continuous woven material. Is the knife razor sharp? If not, we hone it. We set about cutting the carpet into 36 equal pieces, total them up, and find that, lo, there's still nearly 216 square feet of recognizably carpet-like stuff. But what does it amount to? Have we got 36 nice Persian throw rugs? No. All we're left with is 3 dozen ragged fragments, each one worthless and commencing to come apart. The edges of fragments are the least diverse as the disturbance intrudes at the edge. And as fragments get smaller, the edge-to-area ratio increases. As fragments get smaller, so does the diversity of the habitat. In part 1, I presented the relationship between diversity and area. Smaller islands are less diverse than larger islands. Habitat fragmentation reduces diversity. Habitat fragmentation creates islands with populations that are genetically isolated from one another. Are there migration corridors? Is there the possibility of recolonization if a species goes extinct? As well, habitat fragmentation creates islands that are more vulnerable to predators and diseases, islands that are more vulnerable to catastrophic events, and islands with small numbers that make species more prone to extinction. In this Google Earth image of Thailand, you can very nearly make out the political boundary of the country on the basis of deforestation. This photo displays an experimental area in South America that's examining the area size of fragments and diversity. Scientific work needs to be done to better understand the impact of people on Earth. Remember that habitat islands are more vulnerable to predators and disease, more vulnerable to catastrophic events. The small areas are less diverse. Small populations in these islands are more prone to extinction. and that habitat islands are isolated genetically. The next impact on world biodiversity would be invasive species. Invasive species are also known as non-native species, typically introduced to an ecosystem accidentally, sometimes purposefully. Without natural biological predators or disease, invasive species spread rapidly and reduce local diversity. Invasive species could be thought of as biotic pollution. Here are some examples of non-native species that have reduced the diversity of the ecosystems into which they've been introduced. The brown tree snake, by way of example, has been introduced to various islands in the Pacific, such as Guam. The snake has spread rapidly without natural biological predators or diseases. The brown tree snake has decimated bird populations as it eats their eggs. Invasive species are typically R-selected pioneer species. They have high dispersal rates, and they are generalists in terms of the niche that they hold in an ecosystem. The zebra mussel was introduced to the Great Lakes of the United States by ships reaching the lakes from overseas. The zebra mussel spread rapidly, clogging the drains of water systems that access the lakes. Water hyacinth, seen here in Uganda, is invasive and grows abundantly in the waterways of the world. The hyacinth, as a floating plant, blocks sunlight from reaching depth. And water hyacinth blocks shallow bays, requiring removal, as can be seen here. The removal of water hyacinth is expensive. Kudzu is a non-native species that has entered the southern United States. The kudzu vine overgrows other species, outcompeting them for light, ultimately killing the species on which the kudzu grows. Kudzu costs the U.S. $137 billion per year in eradication programs. Prosopis juliflora, commonly known as juliflora, is a non-native species in India. Prosopis grows rapidly in a dry environment, using its deep roots to get groundwater. Prosopis outcompetes native species, reducing local diversity. The stoat, a short-tailed weasel, introduced to New Zealand, eats the eggs of endemic birds, reducing local diversity. New Zealand authorities have initiated programs to eradicate the stoat using traps. Nile perch were introduced to Central African lakes in the mid-1950s. The Nile perch has been responsible for a significant decline in native fish species, various species of cichlids in particular. While the Nile perch have provided food to the populations of people that live around the Central African lakes, their size, as can be seen here, has required stronger fires on which to cook them, thus deforestation. Deforestation has resulted in changes to the quality of the water, making the water more turbid. Both the Nile perch and the turbidity of the water due to deforestation have had negative impacts on the cichlid populations in the Central African lakes. Many of the foods we eat are non-native species in the locations where we grow them. In IBESS Biodiversity Conservation Part 5, we will look at the last impacts of people on the biodiversity of the Earth's species. We will look at human population growth, pollution, and the over-harvesting, over-hunting of species. And that brings us to the end of IBESS Biodiversity Conservation Part 4.